Have you ever stopped to consider the ground beneath your feet? What if we told you that this often overlooked element is the unsung hero of our ecosystem? Yes, we're talking about soil. It's so much more than just dirt. It's a living, breathing entity that supports life on Earth. Nestled within the layers of this humble, earthy matter lies a bustling world of activity, a complex composition of minerals, organic matter, and an array of microorganisms. Each element working in harmony to create a fertile and healthy environment. Soil plays a pivotal role in our ecosystem, perhaps more significant than you might think. It's not just about providing a foundation for plants. It's about fostering life, supporting biodiversity, and maintaining the delicate balance of our planet's ecosystems. So, let's dive deep into the world beneath our feet and uncover the science of soil. Let's pay homage to the unsung hero of our ecosystem. Soil isn't just one thing, it's a mixture of many different components, each playing a vital role in its fertility and health. Let's dive into the first main component, minerals. Minerals make up about 45% of most soils. They're the weathered remnants of rocks, and they provide the structure for the soil. Depending on the type of rock they came from, these particles can be large, like sand, or microscopic, like clay. But it's not just about structure. Minerals also hold essential nutrients for plant growth, like phosphorus and potassium. Next, we have organic matter, taking up approximately 5% of the soil. It's the product of decomposed plants and animals, and it's dark and rich, often called humus. Organic matter is a storehouse of nutrients that can be slowly released into the soil. It also improves the soil's structure, making it easier for roots to penetrate and for water to infiltrate. But soil is more than just a lifeless mixture of minerals and organic matter. It's a bustling city of microorganisms, making up roughly 50% of the soil. Bacteria, fungi, protozoa, and countless other tiny creatures call the soil home. These microorganisms break down organic matter, releasing nutrients into the soil. They also form symbiotic relationships with plants, helping them absorb nutrients more efficiently. Let's not forget about the remaining part of the soil, which is made up of air and water, filling the spaces between the minerals, organic matter, and microorganisms. These elements provide the necessary conditions for life in the soil, with air supplying oxygen and water acting as a solvent for nutrients. So, there you have it. Soil is a complex blend of minerals, organic matter, and microorganisms, all working together to create a fertile environment for plant life. It's this intricate network of interactions that gives soil its life-supporting power. And it's not just about supporting plants. Soil also plays a critical role in maintaining the balance of our planet's ecosystems, from carbon storage to water purification. Understanding these components is key to understanding the function of soil in our ecosystem. The soil is a bustling city of microscopic life, and these tiny inhabitants play an enormous role in soil fertility. Imagine, if you will, an underground metropolis teeming with activity. Each microorganism playing a role, each contributing to a larger, more complex system. This is the world beneath our feet. A world where soil microorganisms and plant roots coexist in a symbiotic relationship that is as fascinating as it is vital. Let's delve deeper into this subterranean city. Picture the plant roots reaching deep into the soil. They are not alone. Amongst them, a multitude of microscopic life forms, bacteria and fungi thrive. They form a network, a web of life that intertwines with the plant roots. This is not a random occurrence, but a strategic alliance, a symbiosis that benefits both parties. So how does this symbiosis work? Well, it's all about give and take. The plant roots exude sugars and other organic substances that are a feast for the soil microorganisms. In return, the microorganisms break down organic matter and minerals in the soil, transforming them into nutrients that the plants can absorb. It's a perfect example of nature's reciprocity, a beautiful dance of mutual benefit. But it doesn't stop there. This symbiosis also contributes to soil structure and stability. The networks formed by fungi, for example, help bind soil particles together, creating a stable environment for plant growth. They also improve the soil's water-holding capacity, preventing erosion and enhancing fertility. Moreover, these microscopic citizens of the soil also play a role in the carbon cycle. By decomposing organic matter, they help sequester carbon in the soil, contributing to climate change mitigation. Thus, the symbiotic relationship between soil organisms and plant roots is not just a local affair. Its influence extends far beyond the immediate soil environment, impacting global ecosystems and the health of our planet. These microorganisms may be small, but their impact on soil fertility and ecosystem health is colossal. Soil is not an infinite resource. It takes thousands of years to form but can be destroyed in just a few decades. This sobering fact brings to light the urgency of soil conservation. The rich, fertile soil that blankets our planet, that sustains forests, grasslands, and farms, and that supports a myriad of life forms is under threat. The threats to soil health are many and varied. Erosion, for instance, is a natural process that can be exacerbated by human activities. Deforestation and poor farming practices strip the soil of its protective vegetation cover, making it vulnerable to being washed or blown away. The result is a loss of fertile topsoil, which can lead to reduced agricultural productivity and, in extreme cases, desertification. Then there's pollution. Industrial activities, improper waste disposal, and excessive use of chemical fertilizers and pesticides can contaminate the soil, rendering it unfit to support life. This not only impacts the plants and animals that rely directly on the soil, but also those higher up the food chain, including us humans. These threats make soil conservation an imperative. But what does soil conservation entail? At its heart, it's about adopting sustainable farming practices. This includes techniques like crop rotation, which prevents nutrient depletion, contour plowing, which reduces erosion, and organic farming, which avoids the use of harmful chemicals. But it's not just up to farmers. We can all play a part in soil conservation by composting organic waste, reducing our use of plastic, and supporting businesses that prioritize sustainability. Soil conservation is a shared responsibility. It's about recognizing the value of the soil, not just as a medium for plant growth, but as a critical component of our global ecosystem. It's about understanding that the health of the soil is inextricably linked to the health of the planet, and ultimately, the health of all life forms that call this planet home. Soil conservation isn't just about preserving the ground beneath our feet, it's about safeguarding the future of life on Earth. Let's not take this precious resource for granted. Let's cherish it, protect it, and pass it on to future generations in better condition than we found it. Be sure to like, comment, and subscribe for more content like this. Hit the notification bell so you never miss an upload. Thanks for watching Random Realm.
It's London Lee.